Hello and welcome back. So this video is for class 11 and today we'll start with chapter 5, laws of motion. Now of course if you see we are talking about laws of motion which is basically the Newton's three laws of motion which first time we had studied in 9th class. Now according to the new syllabus these three laws, they are not part of our syllabus, so no questions and all will be asked from them. But still please make sure that you are revising the laws, right? Newton's first law, second law and third law, and also the principle of conservation of momentum. In the notes already I have included all these questions. No need to write them in the classwork notes, but yes, we should know what these laws are because they are very fundamental laws, right? Whatever we are studying, it is basically a derivation from these three laws, right? Whenever we study anything in motion, right? So having said that, now let us start with the topics for this chapter. Now please pay attention in the discussions that we are having, which topics are included, which are deleted, right? So you should not do any the writing part at least. Make sure deleted topics you are not writing in your notes, right? So as I said, three laws of motion are deleted. Conservation of momentum also is not there. We will start with the topic that is friction, which is in the syllabus. Okay, so friction also, it is not a new concept for us, right? We know that whenever two surfaces are in contact and if they are having a relative motion, there will be friction between them, right? So we know that we are able to walk on a surface because when we are walking, there is friction between our feet and the floor, right? Even when we are writing on the board, there is friction between the chalk and the board. Correct. So whenever two surfaces are in contact and they are having some relative motion, there will be a force of friction present. Here we are going to see the types of friction and also we will see a method to measure the frictional force, because I am sure till now we have not done that. In 9th class, whenever we studied about friction, we never had a formula to measure that friction. So let us see. So we are having three types of friction. The first type is called as static friction. Okay. So of course, when you read the word static, immediately what comes to your mind is the object would be at rest. Correct? So static friction, basically if you are having, let us say there is an object of mass m, it is placed on a surface, there is going to be a static friction between this object and the floor. Okay. How do we define static friction? Static friction is the frictional force that will tend to oppose the impending motion. So when you read this word impending means the motion that would have taken place. It has not taken place because of friction, but the motion that would have taken place if there was no frictional force. That is the meaning of impending. So static friction, it will try to oppose the impending motion, correct? And then how do we understand the static force? Let us say m is the mass of this object. We are going to find out something called as the normal force. Okay, normal force is basically force that is perpendicular to the surface. Okay, to the surface of the two objects which are in contact. Correct? And how much will be the perpendicular force? Obviously, you will know it will be equal to m into g, mass into acceleration due to gravity. So there is going to be a normal force of m into g. Okay, so let us call it as capital N. Weight will be in the downward direction, normal force will be in the upward direction. This also you will remember. Okay. Next, the formula for static friction. So we will say that the frictional force Fs, okay, the frictional force Fs max will be directly proportional to the normal force. So Fs max proportional to normal force. We are writing the word Fs max. See, normally there would be some friction force. If you go on applying more force to move that object, the friction force will also increase, correct? Because the impending motion has increased. So the maximum frictional force will be proportional to the normal force. Okay, and therefore now to remove the constant, sign of proportionality, we'll add a constant. So we'll write Fs max equal to mu s n. This mu s is called as the coefficient of static friction. Okay, so we'll get the formula. Fs max is mu s into n. Mu s is called as coefficient of static friction. Obviously, mu s will be equal to Fs upon n, right? And since this is also force, n is also force, so mu s will not have any unit. So coefficient of static friction can be defined as the ratio of maximum frictional force to the normal force, correct? And there is no unit for mu s. Okay, so that is about static friction. The second type of friction is kinetic friction. Now when you read the word kinetic, again you understand kinetic means it will denote motion. Okay, so basically kinetic friction will develop when object is actually moving on a surface, correct? It is also termed as sliding friction sometimes. So kinetic friction will be when the object is actually moving. So when that movement is taking place, that friction we call as the kinetic friction. Then what is the formula we get? We get Fk, kinetic friction we show by Fk. We say that Fk is directly proportional to N, that is the normal force, and therefore we will say Fk max. So we will say Fk max will be equal to mu k into N. Mu k will be coefficient of the kinetic friction. Okay, and again mu k will be Fk max upon N. It will not have any SI unit. Okay, so when the object is actually in motion, that friction we call as the kinetic friction. Now experimentally it is found that the sliding friction, coefficient of sliding friction is always larger than coefficient of kinetic friction, correct? What it means is that when we try to move objects, if they are stationary, it is more difficult to move them, correct? There is more static friction. But once an object has actually started moving, now we will see it moves much easily because the kinetic friction is always less. Okay, so these are the concepts of static friction and kinetic friction. Now here are some things that you will remember about static and kinetic friction. When you see the formula for static friction, correct, we write Fs max is equal to mu s into N, and we write Fk max is equal to mu k into N. Here we are taking only two things in consideration, the coefficient and the normal force. So it means that for static friction, kinetic friction, the area of contact does not come into the picture. Okay, this is very important to remember. How much area is actually in contact, that does not matter. So even if a very small area is in contact or a very large area is in contact, the frictional force will remain the same, correct? Of course, it depends on mu s, that is coefficient. This coefficient will depend upon how these two surfaces are related to each other, correct? And it will depend upon the normal force. Normal force will definitely depend upon mass and the acceleration due to gravity, but it does not depend upon the area in contact. Second thing about kinetic friction, kinetic friction will not depend upon the velocity. So it doesn't mean that if the velocity has increased by a large amount, the kinetic friction will change. Okay, so these two things you will remember, that they don't depend upon the area of contact and the velocity. Sometimes such kind of question may be asked. So frictions, they only depend upon the coefficients and the normal force. Okay, and of course third type of friction is called as the rolling friction. Rolling friction we will get if you are having a circular object, a sphere or a cylinder. Okay, if it is rolling on a surface, when object is rolling, only one point is in contact with the other surface. When that friction is developed, that is called as the rolling friction. And obviously rolling friction is always the least. So static friction is very high, kinetic friction is lower than static friction, and rolling friction is the least. And of course it is because rolling friction is the least that we have circular wheels, right? Because our cars, we are able to run our cars at high speeds because they are rolling, right? And they roll, they have very less friction. Okay, so these are the three types of friction. So for now we will stop. The task for you is now you are going to read these topics from the textbook. Okay, definitely read Newton's 3 laws and conservation of momentum, correct? Although not in the syllabus, the knowledge is very essential. And just go through the concepts of static, kinetic and rolling friction. In the next class, we are going to see some numericals based on these types of friction.